Good morning to one and all present here, and today we are going to see the lecture number 34, that is in continuation of yesterday class. It will be a solved problems in MMF and EMF method. The problem, because I already solved two problems in the previous day before yesterday class, and today I am going to solve three problems. And the first problem which I am going to solve it by today, a 2300 volt 50 Hertz 3-phase star connected alternator has an effective armature resistance 0.2 volts, a field current of 35 ampere, produces a current of 150 ampere on short circuit, and an open circuit EMF 780 volt, that is line. Calculate the voltage regulation of 0.8 power factor lagging and 0.8 power factor leading. 0.8 power factor lagging, 0.8 power factor leading for the full load current of 25 ampere. Okay, first we will write the what you have to calculate. It will be voltage regulation at 0.8 power factor. First we will write the given data. Given data. What is line voltage? It is the machine will be star connected alternator. Okay, it is a star connected. Star connected alternator. The line voltage will be VL equal to 2300 volt. Are you able to hear my voice? Students, my voice is audible now?
Yes, sir.
Okay. VL equal to 2300 volt. Okay. And frequency. Frequency F, yes, supply frequency 50 Hertz. 50 Hertz. 50 Hertz. And the resistance here, it's having effective armature resistance. What is the notation of armature resistance? RA. RA equal to 0.2 ohm. 0.2 ohm. Then a field current of 35 ampere produces a current of 150 ampere on short circuit. Okay, a field current of 35 ampere, that is IF equal to 35 ampere, which produces a current of 150 ampere during short circuit condition, that is ISC. Short circuit current will be 150 ampere, because when the machine will be in short circuit, the current value is very high. Okay, the current value will be very high, that is ISC equal to short circuit current 150 ampere. Then a open circuit EMF, that is voltage 780 volt. Open circuit voltage will be VOC. It is line. Okay, within a bracket you can mention line. Line equal to 780 volt. Line voltage equal to 780 volt. And the machine is star connected. Now how to calculate, because whatever the parameter which we are going to substitute in voltage regulation, everything should be phase. Okay, everything should be a phase voltage, phase current, like that. Okay, so the line values we have to convert it to phase value. So in star connected, because the machine is star connected, in star connected, what is the relationship between Voltage and current, voltage, line voltage and phase voltage. Anyone? Can you please unmute your mic and please speak, because it should be a more interaction will be there to solve the problem. Please unmute your mic and please speak. What is the formula for star connected voltage and current? In star connected, formula for voltage and current. Anyone? Lakshmipati? Lakshmipati? Lakshmipati is there? Lakshmipati absent. Okay. Students, are you hear my voice or not?
Yes, sir.
What is the star connected formula?
Sir, for voltage, VL is equal to root 3 into VPH.
Good. V line equal to root 3 into V fix. Okay. So what is VOC line? It is VOC, open circuit line. VOC line equal to root 3 into VOC into phase. Okay. VOC phase voltage. So therefore VOC phase equal to VOC line divided by root 3. Okay, divided by root 3. So what is VOC line? 780 divided by root 3. Can you please anyone tell me the answer? VOC phase. What is the answer, ma? VOC phase 780 divided by root 3.
450.33, sir.
Good. 450.33 volt. Okay, 450.33 volt. Okay, now we have to calculate impedance ZS. Okay, next step, ZS. Impedance ZS equal to ratio of voltage divided by current. Okay, voltage means VOC phase, open circuit voltage divided by short circuit current. This also should be in phase. Okay, everything we have to represent in phase symbol. Okay, everything we have to represent phase. So VOC phase we already got it, 450.33 divided by ISC phase. ISC phase means it is 150, because in star connected the line current equal to phase current. Okay, line current equal to phase current in formula. Okay, as per this formula I am taking ISC phase will be 150. So what is the answer, ma? ZS how much?
3, sir.
3 ohms. Good. 3 ohms. Okay, therefore ZS equal to 3 ohms. This is ZS. ZS 3 ohms, and VOC phase will be 450.33. Okay, then we have to calculate a reactance. XS equal to square root of ZS square minus RA square. Okay, how I written this formula? The normal formula, ZS equal to square root of RA square plus XS square. Okay, so by using this formula I am writing this XS. Now substitute it. ZS value how much? It is 3. 3 square minus RA how much? It is 0.2 square. Okay, so what is the answer? Anyone? Please.
2.99, sir.
Good. XS equal to 2.9955 ohms. The unit of reactance will be ohms. Okay, reactance ohms. Okay, now we have to find out the parameters. That is, the first subdivision will be, as per your problem, the first subdivision will be calculate the voltage regulation of 0.8 power factor lagging. Okay, calculate, that is voltage regulation. You have to calculate voltage regulation of 0.8 power factor lagging. Okay, 0.8 power factor lagging. Okay, so what is the voltage regulation formula? Voltage regulation formula, anyone? Voltage regulation formula will be percentage regulation is equal to E phase minus V phase divided by V phase into 100. Okay, this is the voltage regulation we have to find. We don't know V phase, we don't know the E phase. Okay, this V phase and E phase we have to calculate it. So how to calculate this V phase value? V phase is equal to V line divided by √3, because it is star connected. So what is the line voltage, ma? As per your given data, what is the motor specification? How much? It is VL 2300 volt. Okay, so this value substitute here, 2300 divided by √3. So what is 2300 divided by √3? How much? What's the answer, students? Anyone? 2300 divided by √3. Girls? 1327.905 volt. Okay, 1327.905 volt. Understood? V phase calculated. Okay, V phase will be minus 1327.905 whole divided by 1327.905 into 100. Okay, now what is the missing term? E phase. Okay, E phase will be a missing term. This E phase only you have to calculate it. So what is the formula for E phase? Anyone? Anyone? Can you please give me the reply? E phase formula. Students, please give me the reply. E phase. E phase value. Formula for E phase. E phase is equal to, what's the formula? Anyone? Square root of V phase cos phi plus IA RA whole square plus V phase sin phi, okay, sin phi plus IA xs whole square. Okay, students, please listen carefully. In this point we are going to calculate lagging power factor. Okay, lagging. Okay, so please take down note for lagging power factor. Lagging power factor which is applicable to inductive load. Okay, lagging power factor which is applicable to inductive load. So for that purpose we have to put plus symbol here, this term. Okay, this term we have to put plus symbol in terms of reactance, because reactance term is only applicable to inductance and capacitance. Those plus sign we have to include it for lagging. Okay, for lagging, please take down. So now I am going to substitute the parameters. Square root of, can you please tell me what is a V phase? One by one. V phase how much? Girls, Sahana, Grishma. Lakshmipati, please give me the reply. Don't type it in chat box because I can't see the chat box now. Okay, so please give me the reply.
1327.905.
Wait. 1327.905. Okay, into, and cos phi we have to calculate, right? It is 0.8 per factor. So 0.8 per factor means cos phi is 0.8 per factor. Okay, this value substitute 0.8. Understood? Plus whole bracket, put whole bracket, plus again IA. What is the IA value, ma? As per your problem, how much field current? IA how much? Anyone? Hmm? IA phase. IA phase will be how much? It is 25, or how much full load current as per your given data? You see here in the question.
So 150.
No. 150 is the short circuit current. Here the full load current will be 25 ampere. Okay, this is the full load current, IA phase. IA phase will be 25 into IA phase. Please take down. IA phase equal to, it is line, IA line, armature current, full load current, line equal to, full load line equal to 25 ampere. Okay, into RA how much? Effective resistance 0.2. Okay, whole square plus V phase how much? V phase will be 1327.905 into, what is the sine? How much value, ma? Sine value? Sine phi how much? Anyone? Cos phi equal to 0.8. How much sine phi? 0.6. 0.6. Okay, this value we have to substitute. 0.6 and close the bracket. Okay, then we have to put plus symbol. This plus symbol is applicable for lagging power factor into IA phase. This is 25 into XS how much, ma? What is the answer for reactance term? We already got it right in the step 1. XS 2.9955. 2.9958 whole square. Sorry. Okay, so now please give me the answer. Please give me the answer. Anyone? Use your calculator and give me the answer. E phase.
1559.65.
1950. No, I got
1559.
no. I got 1378.013. Please check. Students, please confirm this answer. Anyone? You got this answer? This is E phase. Please give me the answer. Whether this answer you got it? 1 3.
Yes, sir. It's correct.
Okay.
1
Okay. Now this answer you have to substitute in our regulation. E phase 1378.013. Hold it. Now how much percentage regulation? What's the answer? Please give me the reply. Students? Percentage regulation.
So 3.7.
3.773 percentage. Please put this percentage symbol because the voltage regulation should always represented in percentage. I understand? This is subdivision 1 as per your problem. Okay, so subdivision 2. Subdivision 2 will be, what is second subdivision? We have to calculate voltage regulation for of 0.8 power factor leading. Note for leading power factor, which is applicable to capacitor load, capacitive load. So we have to put minus symbol. Okay, we have to put minus sign. This is note down. Okay, so same formula we have to use. Percentage regulation is equal to E phase minus B phase divided by V phase into 100. V phase we already have. Okay, V phase will be 1327.95 whole divided by 1327.95 into 100, except E phase. Okay, this E phase only we have to find. So E phase equal to formula square root of V phase cos phi plus IA RA whole square plus P phase sin phi. So what I have to put here? Next step. What I have to include? Anyone? V phase sin phi. Then what is the symbol I have to put? Whether it is plus or minus? Yes, plus or minus here.
Plus.
Plus. Plus symbol is minus. It is leading power factor minus. We have to put minus symbol IA XS whole square. Okay. So now substitute all the values. Whatever the value is substituted in the previous subdivision, the same values please substitute it. So we face how much? 1327.95 into cos phi will be 0.8. 0.8 plus IA phase how much ma? 25 into RA 0.2 whole square plus V phase 1327 point, it is 90, sorry, it is 905 905 into sin phi will be 0.6 minus symbol. Okay, we have to put minus into IA value 25 into XS value how much? XS 2.995 whole square. Can you please give me the answer? How much your E phase? E phase, what is the value?
1289.07.
1289.076 volt. Okay, this value substitute here. 1289.076. Okay, therefore regulation is how much ma? What is the regulation?
Minus 2.92.
Yeah, minus 2.94. Okay, why it is minus means it will be a capacitive load. Okay, in capacitive load it will be starts from, because in capacitor it will be starts from integration symbol, lower limit to upper limit. When we calculate the capacitor, we have came to know about 1B equal to 1 by C integral of I dt. By using this relationship, the capacitor is having a leading power factor in terms of minus symbol. Okay, so please take down this minus symbol denotes leading power factor. Leading power factor. Where this leading power factor happen? When we are using a capacitor, capacitive load in our alternator. Capacitive load in our alternator. Any doubts in this problem, students? You have any doubts in this problem? Any doubts? Can I move to second problem? Can I proceed? Can I proceed? Second problem?
Yes, sir.
Okay. Second problem. Okay. This is problem number 2. Problem number 4. Okay. Okay. Please take down. The open and short circuit test readings for a 3-phase star connected. Okay. For a 3-phase star connected 1000 kVA 2000 volt 50 Hz synchronous generator, or one is field ampere, another one is open circuit voltage, third one is short circuit armature current. Okay, these are the readings from the machine. Okay, now the armature effective resistance will be 0.2 ohms per phase. Draw the characteristics curve. Estimate full load percentage regulation for 0.8 power factor lagging, and this is 0.8 power factor leading. 0.8 power factor lagging, another one is 0.8 power factor leading. Can I proceed? Step 1. First step. Step 1. Now, first step, we have to convert this open circuit voltage will be not, it is in line, because we are taking this open circuit voltage from the machine, okay, directly. So whatever the data which we are taking, everything will be a line voltage. Okay, by using the line voltage we have to convert it to phase. For that purpose the machine is having star connector. They are represented here itself. The winding connections inside the machine, it will be star connected machine. So the machine is star connected. Star connected. So we have to find VOC phase. VOC phase is equal to VOC line divided by root 3 divided by root 3. Divided by root 3. VOC line divided by root 3. Okay, so first step, field ampere. I will represent a different color. Field ampere means IF. Okay, IF 10, 20, 25, 30, 40, 50. Okay, 10, 20, 25, 30, 40, 50. Okay, this is our graph. Everybody having graph sheet? Students, you have graph sheet? Students, please give the
Yes, sir.
Okay, now please take your graph paper and draw a line. This point. This is IF. X-axis will be IF. Now I am going to set scale. Scale in our graph. Scale X-axis 1 unit equal to, I am going to set 10 ampere. I am going to set 10 ampere. So 10 ampere. So this is 0, 10, 20, 30, 40, 50, 60, 70. Okay, it is represented in amps. IF. This is my step. Now what I'm going to do, we have to mark VOC phase. VOC phase. So this y-axis, this line will be VOC phase. Okay, VOC phase. This VOC phase is applicable for open circuit characteristics. Open circuit characteristics. Okay. Now, as per your given data, the open circuit voltage will be 800. Okay, this represented in line. Okay, we have to convert it into phase. So how to convert it? Example, this is 800, right? 800 divided by root 3. So what is the answer, ma? 800 divided by root 3, how much? Anyone?
461.88.
461.88 volt. Okay, this value substitute here for 10 ampere. 461.88 volt. Like that, please do it for 1500. Please, everybody, please unmute your mic and tell me one answer, one readings. For
866.02.
866.02. Then for 25 ampere, how much it is? 1760, right? What it is?
1016.13.
1016.13 volt. Then for 30, 2000 divided by root 3. 2000 divided by root 3. Girls, 2000 divided by root 3.
So it's 1154.
1000?
154.
1154.7 volt. Then 40, 2350 divided by root 3. How much? 1356.77 volt. For 50, 2600 divided by root 3. Anyone?
1501.11.
1501.11. Okay, now by seeing this reading, okay, VOC phase, we have to set the scale, okay, for y-axis. This is y-axis. Okay, so for y-axis we have to set the scale. Y-axis 1 unit equal to, I'm setting 200 volt. Okay, for this VOC phase 200 volt I'm setting 200. So this line 200, this line 400, 600, 800, 1000, 1200, 1400, 1600. I stopped here. 1600. Okay, now we will plot one by one. IF 10. Okay, for 10, 461 we have to plot it. We have to plot 461. So where I have to plot it? This 461 for 10, it is 461.88. 461 means it is 400, right? Here. This is my first reading. Then for 20, 866. 866 means here. 866. For 25, how much? 1016. 25. For 30, 1154. This is 1154. Then for 40, it is 1356. Okay. For 50, 1501. 1500. 150. Okay. Now we have to join the line. Okay. Now you have to join this line. So how to join here? This is 0, right? By using your pencil, please join these lines. Don't use a scale, please join. Okay, it's like this. This line will be open circuit characteristics. This line will be open circuit characteristics. Any doubt, students? Have doubts? Any doubt? Open circuit characteristics. Now, as per our given data from our problem, okay, from the problem, step 2. Step 2, as per the given data, the line voltage VL equal to how much? It is 2000 volt. 2000 means it is star connected. So V phase equal to VL by root 3. So 2000 divided by root 3, you will get 1154.7 volt. 1154.7 volt. Okay, then the power equal to, power means you know that power equal to root 3 into VL IL. Okay, VL means everything should be in phase. Okay, VL phase into IL phase. Okay, phase voltage and phase current. So how much power it is? It will be 1000 kVA. 1000 kVA. kVA means kilo 10 power 3 equal to root 3 into V phase will be 1154.7 into IL. So from this, can you please tell me the IL value? Anyone? IL value how much? IL equal to
288.7.
288. Good. 288.6751 ampere. Okay, since the machine will be star connected, in star connected the line current equal to phase current. So this IL is nothing but, okay, this IL which is nothing but IA phase. Okay, IA phase. This IA phase is nothing but full load current. Okay, full load current. Understood? Okay. Now we have to plot a short circuit curve. Okay, short circuit curve. Take down. Short circuit curve, how to plot it? Because as per our question, you see the short circuit. It is 200, 250, 300. So I am drawing, because anyway I have to draw the y-axis. Better I can draw the y-axis here. Okay, in this margin, right hand side. because I should not disturb the left hand side graph. Okay, this is IASC phase. IASC phase. And here also we have to set y-axis. For y-axis, 1 unit I am going to set, because here the readings are already available, 200, 250, 300. I am setting 100 ampere. 100 ampere. Okay, 100 ampere. So this value I am going to write it here. This is 100, 200, 300, 400. Okay, now I am going to plot this field ampere versus short circuit current. Okay, current value in short circuit current value in star connected the same, line current equal to phase current. Okay, this is phase current. Okay, line current equal to phase current, so this is phase value. So how much ma? For 10 it is 0. Okay, for 10 it is 0. Okay, for 20 how much? It is 200. Can we plot? For 20 it is 200. It is 200. Next, for 25 it is 250. This is 25, 250. 250. For 30 it is 300. For 30 this is 300. Okay, short circuit curve should always represent, should be in straight line. Okay, it should be a linear curve. Now please take your scale and draw a short circuit curve. Okay, please take your scale and draw a short circuit curve in a linear, a straight line. A straight line. It should be a straight line. This straight line, call it as short circuit curve. Okay, short circuit curve. Okay. Okay. Now from the graph we have to plot. So how much this IA phase? We got it, full load current 28.67. Okay, 28.67. This value I am going to plot it. Okay, take down. Okay, take down here. From short circuit curve graph for IA phase. IA phase is how much? It is 288.67. Okay, 288.67 means where it is 288.67. So how to plot? Okay, this one will from open circuit curve. First step. First we will plot open circuit graph. Open circuit graph for IF. Okay, IF will be how much ma? IF, it is, what is IF value? IF value you don't know, but we know that VOC phase value will be, it is 1060. Okay, now how to find out means, this IA phase will be 288.67. For 288.67 means this line, 288.67. This is 300. Yeah, this is 288. So please draw the line directly. Okay, so this line will be 288.67 ampere. Okay, so for 288.65 ampere, this line, this dotted line should be touched towards this short circuit curve. So once it will be touched, then we have to draw a parallel line. Okay, parallel line, and this value will be, if you plot it properly, you will get IF. IF will be 28.5 ampere. Okay, so IF will be 28.5 ampere. Okay, so from this 28.5 ampere in open circuit. Now by using this IF 28.5, again project the line towards upward. Okay, towards upward, will get towards the open circuit curve. Once this line touch this open circuit curve, wherever it means, again please draw this dotted line. It will becomes around, okay, this point. This point will be, call it as 1060 volt. Okay, so open circuit phase 1060 volt. Are you understand? Okay, now by using these parameters, now we can calculate the ZS. ZS is equal to VOC phase divided by IASC, short circuit current phase. VOC phase will be 1060 divided by IAC phase will be 288.67. So we can get it 3.672 ohms. As per your given data, the RA value is already available, 0.2 ohms. Now by using this value, we can calculate XS. XS is equal to square root of ZS square minus RA square. Substitute these two, you will get 3.667 ohms XS. Okay. Now as per our question, the first subdivision we have to calculate, estimate the full load percentage for 0.8 power factor lagging. Okay, you have to calculate for lagging power factor, 0.8 power factor lagging percentage regulation you have to calculate. Okay, the same formula you have to use it. The formula will be E phase is equal to square root of V phase cos phi plus IARA whole square plus V phase sin phi. You have to put plus symbol. This is lagging, plus IA XS whole square. So we can get it, square root of V phase will be 1154.7 into power factor is 0.8 plus IA will be 288.67 into RA is 0.2 whole square plus V phase 1154.7 into sin phi 0.6 plus symbol. You have to put plus symbol. Plus, have to put plus symbol into IA 288.67 into XS. XS value will be 3.667. 3.667 whole square. So finally E phase value we are getting 2007.6615 volt. This is E phase. Now by using this we can calculate the regulation. What is the regulation formula? Percentage regulation is equal to E phase minus V phase divided by V phase into 100. So E phase value will be 2007.6615 minus V phase value, which is we already have. V phase value will be 1154.7 from our given data, divided by 1154.7 into 100. We'll get the answer. Percentage regulation 91.18%. This is my answer. Okay, so similarly you can do it for leading. For leading power factor we have to put minus symbol here in this notation. So the answer is E phase is equal to 1047.4286 volt and the percentage regulation will be minus 9.29%. Minus 9.29%.